So we need to solve the system of equations using matrices, and we need to use a Gaussian elimination method with back substitution. So the system can be written in its matrix form, which is x, which are coefficients and constants. So coefficients in the first equation are 1, 4, 0, and the constant is 0. In the second equation, it's 1, 5, 1, and the constant is 1. And in the third one, it's 5, -1, -1, 79. Now we will perform some basic row operations. The first thing that we do is we subtract the first row from the second row. So row 2 becomes row 2 minus row 1. And here, so the first row and the third row stays the same. However, the second row changes, and in the second row we have 0, 1, 1, 1. Our next step is to multiply row 1 by 5 and to subtract it from the third row. So row 3 becomes row 3 minus 5 times row 1. And our matrix is 1, 4, 0, 0, 0, 1, 0, 0. And here we have 0, -21, -1, 79. Next step is to multiply second row by 21 and to add it to the third row. So row 3 becomes row 3 plus 21 times row 2. And our matrix looks like this. It's 1, 4, 0, 0, 0, 1, 0, 0. Here we have 0, 0, 20, 100. In the next step, we divide the third row by 20. So row 3 becomes row 3 over 20. And we get 1, 4, 0, 0, 0, 1, 1. Oh, sorry. I don't know why I wrote this like this. Here we have 1, 1, 1, 1, 1. And here we have 0, 0, 1, 5. And our last step is to subtract third row from the second row. So row 2 becomes row 2 minus row 3. And we get 1, 4, 0, 0, 0, 1, 0, -4, 0, 0, 1, 5. And our last step is to multiply our second row by 4 and subtract it from the first row. So row 1 becomes row 1 minus 4 times row 2. We get 1, 0, 0, 16, 0, 1, 0, -4, 0, 0, 1, 5. As you can see we have reached the reduced row echelon form. So now we see that x equals 16, y equals -4, and z equals 5.